Hi guys, so this week you were supposed to be turning in 2 assignments. One of them was the thermochemistry quiz, which covers last week's stuff. And one of them is starting our new unit, which is called quantum mechanics. I'm gonna make another video about quantum mechanics, like right after this one, and I'll send them both, but I want this one to be really short and sweet so you can just watch it and then take your quiz this week if for many reasons you were not prepared from last week. As I'm looking through last week's assignments, a lot of you didn't do them, for one. Some of them was very obvious you copied, for 2. For 3, some of you did them, but they were inaccurate. And some of you did a really good job and it looked like you did it all on your own and was correct. So kind of all of the above, but I just wanna make sure that you know what you're doing before you take your quiz. So I'm gonna run through basically everything that you should have learned from last week as quick as I possibly can, just touch on like the highlights. But I do wanna remind you that we post video notes in the resources page every single week for these notes. It is literally being taught, the exact same notes being taught. It's not being taught by me, it's being taught by Pam Youngman. She's our AP teacher, if you didn't know that. This is my dog Archer, sorry. But she's the AP teacher at our school, and she made those notes ages ago for kids who were absent, but they are our notes. They have already been made, they've been like accessible to y'all on Canvas in the past. Just maybe you didn't need it because you had me anyways. But now you have those video notes and you should watch them because then you'll actually learn. Trying to guess chemistry is not easy to do, but watching her teach you it is the same as being in class. Okay. So I'm going to run through a couple things real fast. So here's the 2 graphs for thermochemistry. We have exothermic and endothermic. So if you look at this one really quick, just looking at what it does, it starts up high and it ends up low. What it's doing is it's losing energy. So what that feels like is it's going to feel hot. So any reaction we have ever done in class that gets warm is an exothermic reaction because they give off heat. So what they're doing in this reaction right here, a lot of you missed this. So here's the little product arrow. So these 2 things come together in a reaction. They create this stuff and they create energy. That energy that is created is felt as heat to us, but that is what an exothermic reaction does. It gives off heat. So it's on this side of the arrow. Now moving it up. If we're looking at this one, it's the exact opposite. It starts low and gets high. So it is gaining energy. So what it actually feels like is cold because it absorbs energy from the surroundings. It sucks energy out of its surroundings. And you, with that lack of energy because it sucked it in, would feel it as it being cold. So if we've ever had a reaction that felt cold, baking soda and water does this, is an endothermic reaction. So if I'm looking at my little chart here, so these things come together before the reactant. So they are coming together. The energy is being joined in. So it is absorbing energy to create the reaction. So basically the opposite is being done. We have 2 things that give off energy, and we have something that absorbs energy to make it work. Okay. Next, we have these charts right here. So some of you are doing really well, some of you are missing some of these, but it's really pretty easy if you just know where it's at. So if I'm looking at this chart here, the activation energy is the energy needed to go from the start to where the reactant happens. So just, if you haven't watched the videos yet, this is where the reactants start, reactants. They need a certain amount of energy, always, everything needs a certain amount of energy, so they need a certain amount of energy before they will turn into something else. So they will do their chemical reaction thing. This is the amount of energy they need. The activation energy is the energy that they need to activate, okay? So when I'm asking this question right here, what is the activation energy? You just start from where the reactants are and how much is needed. So that's starting at 20, so I need 10, 20, 30, 40, 50, 60. I need 60 kilojoules for this reaction to take place. Next, it says, what is the potential energy of the reactants and the products? Well, that's just where they're starting. So the reactants, it starts at 20, so it's 20. The products starts at 50, so it's 50. That's it. You just literally look at it. That's where they start and where they end. Now for the change in heat, that is always from where it started reactants to where it ended the products. What is the change here? What is the number value change? So if you look at the 20 and the 50, subtract them. What does that equal? 30. The change of heat is 30. 10, 10, 20, 30. That's the change, okay? Then we have, last thing, it talked about catalysts. So if you think back to our lab we did, hopefully you were there. If you weren't, just listen to what happened. So in the lab we did where we had hydrogen peroxide, where hydrogen peroxide comes in a brown bottle. It comes in a brown bottle because sunlight breaks it down naturally. So it's a natural reaction and naturally breaks down into water and oxygen gas. We made that speed up inside a test tube by adding yeast to it and manganese dioxide. Those two things sped it up. They were catalysts, and they made it automatically turn into oxygen. And we could test that by lighting the splint on fire. We dipped into the test tube, and it like lit back up. You could blow it out and then put it back in. It would light back up because oxygen was being created. So yeast and manganese dioxide, which is what we were using, sped up the reaction. A natural reaction that would happen anyways, but we sped it up, creating that gas faster, which is called a catalyst. So if I'm looking at a catalyst on the chart, all it does is speed it up. How does it speed up the reaction though? It lowers the amount of energy. So remember, this is the energy I need to make the reaction go. This is the energy I need. Well, now I don't need that much. I only need this much from here to here. That's what a catalyst does. It makes the amount of energy I need for a reaction to happen less. So then that would make it speed up if I need less energy. Okay. Last part was probably the thing that was missed the most. And to be honest, it's pretty easy. It's probably easier than all of that. It's just math. So I feel like a lot of you didn't look at the notes or didn't watch the video, so then didn't know what to do. So if I'm looking at this one, we're just going from Kelvin to Celsius or from Celsius to Kelvin. So those are two different temperature scales that the world uses. I know that we use Fahrenheit, but that is not what the world uses or what the realm of science uses. They use Celsius and Kelvin. So that's what we have to learn to convert in between in science. So if I'm going from Celsius to Kelvin, all I do is add 273. So you can see that. You just add 273 to it. Done. Now if I'm going from Kelvin to Celsius, I do the opposite. I subtract 273. So you can see my formula. I subtract 273. That's your answer. These are actually in your worksheet. If you notice, all the ones all these that I'm doing are actually from your worksheet. All right, so this problem here, I'm gonna have to turn it so I can read it. Says how much heat is required to raise the temperature of 25 grams of aluminum from 25 degrees Celsius to 100 degrees Celsius. Specific heat of aluminum is 0.21, and that you would have got from charts in your notes. On quizzes and tests, I would just give it to you though. So I need to fill in my formula. Q equals M times C times change in T. You literally just multiply the numbers together. It's just multiplication. So if I look at it, I'm trying to find heat, which is Q. How do I find Q? M times C times change in T. So what is M? That's mass. So the mass in this problem was 25 grams. The C is specific heat, which I told you right down here. You would have got a chart in your notes, but it normally is going to tell you specific heat of aluminum is 0.21. So it's 0.21. And lastly, change in T. So change in T means the change in temperature. So it's not the temperature, it's the change in temperature. So I went from, can't see it, it's backwards to me, from 25 to 100. So what's the change, 25 to 100? It's 75. So that's what's going to go there, 75. I literally just multiply them up. So 25, which is the mass, times 0.21, which is specific heat, times 75, which is the change in T, multiply them together, and you get 393.75. So that was the answer. That is an answer in your worksheet. All right, so hopefully that helped clear things up a little bit. If it didn't, go back and watch the notes video because she's gonna break it down way slower. I just tried to hit all the high points really quickly. You need to watch this and then go take that quiz. If you failed the quiz, you've already taken it, if you've noticed, I've opened it for you to take it again. So take it again until you pass it, okay? If you need any help, ask. I'm here, and I've had, I think, 2 children ask me questions. That's it. Ask me more questions if you are struggling. All right. Thank you.